Putting the fun into IPv4 fundamentals. Let's begin. If you, like me, find that time is very, very valuable, I want to make sure I optimize both of our time together. What I'd like you to do is I'd like you to pause the video and read through each of these 4 questions. If you can correctly answer and are comfortable with each of these questions, go ahead and skip this specific video, and I'll see you in the next video in this course. If, on the other hand, you find that you're not quite yet comfortable with one or more of these questions, have no fear, because you and I are going to address each one of these in this video. I'd like you to visualize in your mind's eye the home where you currently live. Whether it's an apartment, maybe it's a condo or a house, I'd like you to visualize what the roof looks like, what the front door looks like, and also I'd like you to look at, in your mind's eye, the address on your house. So I'm going to draw this house, and let's say the address, just for our example, is 123. Now I know that house number that you have might be slightly different, but one common thing that all homes have is they have an address. And not only do they have a house address, they also have a street address. For example, your neighbor over here at 125 and your neighbor over here at 121. They all have house addresses and they are all connected to the same common street. So let's say this is Elm Street, and I've got a question for you. Why is it that we use street names and house addresses as part of an address? In fact, why do we have addresses at all? And you might be saying, well, Keith, you have to have an address. For example, let's say that the mail carrier wanted to deliver mail to this house. If the mail carrier didn't have any idea about streets and house numbers, these addresses, if you will, we wouldn't have the ability to deliver or even get to a specific location. And that, my friend, is absolutely true. Addresses are very, very handy in the real world that we live in for both knowing where places are as well as the ability to deliver something like a piece of mail to that destination. Well, in computer networks, we also have devices, and we call them lots of things on networks. We could call them, for example, a host, or a node, or a server, or a PC, or a network printer, but they're all devices that sit on networks. And they also have host identifiers, similar to a house number. For example, this may be 121, this may be device 123, maybe this is device 125. And because they are all connected, in this example, to the same network, maybe this network is First Street. Now in computer networks, we don't actually call it streets, we call them networks. So I could actually say, instead of First Street, we could call this network number 1. So this device right here could be addressed, if you will, from a logical IP version 4 addressing system as being host number 121 on network number 1. Just like this house is house number 121 on Elm Street. And what's the benefit of that? Now the cool thing is that if we ever need to deliver packets, for example, to 121, this host at this host address on this network, because we have this logical IP addressing, which is very similar to street names and house numbers, we now have a method of identifying an individual host, an individual device on that network, so we can forward data called packets to that destination. So in answer to these first 2 questions, what exactly is an IP address? It's a logical addressing system that identifies networks that are common to devices and individual host addresses for each of those devices on that network. And why do we use them? The answer is simple. It is for the exact purpose of being able to send data to a specific device on a network, based on a layer 3 IP address. Let's chat about what an IP version 4 address would look like if we were to see one. Now, in the example of our house and the street names, we had house number 121, Elm Street. That's pretty straightforward because we're used to it. With IP version 4 addresses, instead of using names for the streets, we actually use numbers. And it would go something like this: 11.23.14.95. And these periods here are the just separators between the numbers. So an IP version 4 address is 4 numbers, 4 decimal numbers separated by periods. And a lot of times people say, well, what's up with the periods? Why are they important? Well, if we didn't use the periods and we just had an IP address of like 11, 23, 14, 95, that might be misinterpreted to mean, oh, it's 112 for the first number, 3 for the next number, 149 for the third number, and 5 for the last number. So the periods here are simply visual and representative separators between the 4 decimal numbers. So here's our first number, second number, third number, and fourth number. And the periods are separating them. So whenever we hear the term dotted decimal, all we're talking about is a format where we have 4 individual numbers separated by periods. Now, one of the cool things is that everybody who's connected to a network is going to have an IP address of some type. The biggest IP version out there at the moment is IP version 4, and that's what this series and this course is all about. There's also IP version 6, which has been making inroads for many years, and if you want to learn more on that, go check out my IPv6 series dedicated to that subject at CBT Nuggets. IPv4 is still going strong and is still the most popular IP version being used on the planet today. So how exactly do we find our IP version 4 address? And the answer is really simple. If you're on any version of Windows, you simply run the command ipconfig, just like that, and it's going to reveal to you your IP address. If you're on a Macintosh, you can use ifconfig, and that will show you your IP address. If you're on a Linux box, you can also do ifconfig, and that will show you your IP address. And if you're on some type of a PDA, in the settings, it'll also be able to show you what the current IP address is on your device. And for most of the computers that are connected to IP networks, that IP address assignment of how you actually got that IP address to use is done dynamically through a protocol called Dynamic Host Configuration Protocol, so that you don't have to manually plug in an IP version 4 address. You are automatically assigned one. So here's what I'd like you to do. Whether you're on a Macintosh or Linux or any flavor of Windows, I'd like you to right now identify what the IP address is that is running on your computer. So again, if you're on Windows, you can do an IP config like I'm doing right here in this demonstration. And what this is showing me is that my IP version 4 address is 192, that's the first number, 168, that's the second number, 1, that's the third number, 15. And the little periods are simply separators between the numbers, so we know where one number starts and the other number stops. And if you're on Macintosh or on Linux, you'd run ifconfig to get similar results regarding what your IP address currently is on your device. So here's what I want you to do. If you haven't already, go ahead and pause me and then run ipconfig or ifconfig on those other platforms just to validate what your IP version 4 address is, and I would like you to write that down on some type of paper. Once you've jotted that down, go ahead and give yourself a pat on the back. Great job. Because, my friend, it's small incremental steps that are going to give you the skills, the expert skills that you need as you master not just IP version 4, but also IP version 4 custom subnetting. The next thing that you and I absolutely deserve to chat about is dividing lines. What do you mean, Keith, dividing lines? Well, you know, in a house and street, there's the actual house number, like 123, and then there's a space, and then you have like Elm Street. So the mail carrier knows exactly what the house number is versus the actual street. Well, in an IP address like this one, we'll use mine as an example. In this address, which appears as 4 numbers separated by 3 periods, that's the dotted decimal format, the reality is that a portion of this IP address is representing the actual street or network. And unlike like Elm Street with house addresses, we put the actual network portion first, and then we have a dividing line, and then we have the actual host portion. So this would be like the street, and this would be like the house number. So if this is your first exposure to how IP version 4 addresses work, you just got to get used to the idea that they're going to put the street name first, which is just a number, and then the house number after. Now here's the big question. We have 2 parts. We have a network portion and a host portion, and a dividing line. The question is, where is that dividing line? For example, is it between the 192 and 168? Is this all network and this is all host? Or is it in the middle between the first and second grouping? So is this all network and is this all host? Or is it right here between the third and fourth octet, which would make this all the network address and this is the host? For example, if this was the case, where that's where the dividing line was, we could say that the network is 192.168.1 and the actual host or house address, if you will, is 15 on network 192.168.1. So that's the 2 distinct and separate portions of an IP version 4 address is that there's a network portion, which is always going to be somewhere on the left, and there's going to be a host portion, which is always going to be somewhere on the right. Where one stops, the other begins. And now for the million-dollar question, what is it that identifies where that dividing line is? And the answer is, it is the mask. For example, if we took that same IP address of 192.168.1.15, and I'm going to put the mask in green. If we put a mask like this and said these first three numbers, which are also referred to as octets, and we'll get into more of the binary in a separate discussion, but these first three numbers or first three octets, if the mask is indicating that those are all network, meaning they are representing the network, what is implied, which is not explicit, but it's implied, it's implying that the last number, or the last octet here, is available for host bits. So I want you to think of it like hungry, hungry hippos. Whatever the mask devours, for example, in this case, the mask devoured the first, second, and third numbers, and because the mask didn't use or chomp up, if you will, or take the last number is available for host addressing or house numbers on our IP networks. So here's the deal. We are going to get into the details and the math a little bit of behind why that works, but for this video, I want you to understand that the mask's only function, the only function of the mask is to identify where the dividing line is between the network, which is always on the left somewhere, and the host address, which is going to be on the right. Hey, let's do another example just to reinforce that. Let's say we have an address of 10.20.42.99. Now my question for you is, okay, where is the dividing line for this IP version 4 address? Is it between the 10 and the 20, or the 20 and 42, or the 42 and 99? What you should be saying, and what I want you to say is, Keith, I don't know because I don't know what the mask is. For any IP address, it's the mask's responsibility to explicitly say this portion of the IP address is the network. So for example, if I told you that the mask was like this, and now if I asked you, okay, which portion of this IP address represents the actual network address, you'd say, Keith, that's easy. That's the job of the mask. The mask indicated that the first two numbers are exactly the actual network address. And that implies that the last two numbers, which were not consumed by the greedy mask, are available as house addresses, or in the case of an IP version 4 network, host addresses. So the little computer that's sitting on the 10.20 network could have the host address of 42.99, and what we'd actually see on that computer itself would be an IP address that looks like this, 10.20.42.99. It's all put together in one consistent string, and it's up to the mask to identify where that dividing line is between the network portion and the host portion. I have had a blast. Here's the action items I'd love for you to do. I'd like you to revisit those opt-out questions at the beginning of this video to make sure that you are now comfortable with each and every one of those. Secondly, any of the exercises that I've had you do in this video, for example, in this one we did a look at our IP address with ipconfig or ifconfig. If you haven't done that yet, please take a moment and make sure you do these small exercises. Inch by inch, life's a cinch. But big changes are often very difficult. My objective for you in this course is to make it very simple, and if you'll follow along with me step by step, we'll have you doing custom expert level subnetting in no time. So speaking of time, thank you very much for the time you've invested in this video. I hope this has been informative for you, and I'd like to thank you for viewing.